Okay, so our objectives today are to integrate improper fractions. I'm going to go through a bunch of integration techniques really quick, starting with the ones we already covered and then getting into the new stuff. I'm not going to go all the way through this document. We'll continue through it for the rest of the week until we'll finish at the end. So starting with U-Substitution. So U-Substitution is basically chain rule in reverse. If I was going to derive f of g of x, I would end up with f prime g times g prime. So if I wanted to undo this, then I would divide by the derivative of the original inside function. So I would want to divide by g prime, and then integrate the outside function to get back. That does mean that we need to know what the original inside function was first. So if I did that, this would be u is equal to g of x, therefore u prime is g prime x, which would leave me with f prime of u is my derivative of the original function. Therefore, the integral of f prime u du should be my original function. Okay, so for U-substitution, we're looking for what the inside function was, and then we'll resubstitute back in. So for this one, I've got the integral from pi to 3 pi halves of sine and cosine. So if u is sine and u prime is cosine x, then I could say if u is the sine of x and x is pi for my lower bound, then the sine of pi is 0. If u is sine x and 3 pi halves is my upper bound, then the sine at 3 pi halves would be -1. So I could rewrite this as the integral from my lower bound, that's the sine at pi or 0, it's my upper bound, the sine at 3 pi halves, of u times u prime is the same thing as the integral from pi to 3 pi halves of sine x cosine x. So when I integrate this, if I integrate u, I'll divide by u prime, add 1 to the power, and then divide by the new power. Gives me u squared over 2 from 0 to -1. I'll plug in my upper bound and subtract my lower bound. If I do, -1 squared is 1, so that gives me 1/2 minus 0, or 1/2. Any questions on U-substitution from last week? Okay. So one more. Here I've got the integral of 4x over x squared minus 40x. If I set u equal to the bottom part of this fraction, x squared minus 4, then u prime would be 2x dx. I don't have a 2x dx, I've got a 4x dx, so I'm going to break that apart. So this is 2 times 2x dx, or the integral of 2 times u prime over u. If I integrate u prime over u, I'll get the natural log of u plus c, and then I can resub in back for u. Okay, still U-substitution. Okay, then new stuff for today, which before I get into, I'm going to jump back to some pre-calc. If I wanted to divide 215 by 7, I could start to split this up. So 7 does not go into 2, but 7 does go into 21 3 times. 7 times 3 is 21, so I subtract 21 to get 0, and then I can bring down the 5. 7 does not go into 5 evenly, so this is 3 plus 5 over 7 for my remainder, or 215 divided by 7 is the same thing as 3 is 21 over 7, so this would be 26 sevenths. I'm going to do the same process for long division with polynomials. So let's say I had something like x cubed plus 27 over x minus 3, for instance. If I wanted to set this up for long division with polynomials, this would be, I'm dividing x cubed plus 27 by x minus 3. X goes into x cubed, x squared times. So x squared times x minus 3 is x cubed minus 3x squared. If I subtract that from what I had originally, I would get a positive 3x squared. I don't have any more x squareds on top, so I'm just going to go into that. In order to get 3x squared, I would have to multiply x by 3x. So this is plus 3x. 3x times x minus 3 is 3x squared minus 9x. So if I subtract that from what I had originally, I'll get 9x from my next term. In order to get 9x, I'd have to multiply x by 9. So if I multiply 9 times x minus 3, I would get minus 9x minus 27 out of space. Okay, so this is 9x. We said when we multiplied 9 times x minus 3, we got 9x minus 27. So I'm going to subtract that from what I had originally. If I do, this will be 9x minus 9x is 0. And then my 27 that I have on top minus negative 27 is a positive 54. So that's my remainder. So I'm left with x squared plus 3x plus 9 plus 54 over x minus 3 for my remainder. So I could say x cubed plus 27 over x minus 3 is the same thing as x squared plus 3x plus 9 plus 54 over x minus 3. Okay, so that's long polynomial division, back from Algebra 2. Any questions on what we did here? Okay, so where this is going to come in useful for us is anytime we have an improper fraction that we want to integrate. So here I've got x cubed over 1 plus x squared. My top number has a larger power than my largest bottom number. So that says my fraction is improper, so what I'm going to do is I'm going to divide this out. This is x cubed divided by x squared plus 1. If I wanted to get to an x cubed from an x squared plus 1, I would multiply this term by x. So x times x squared is x cubed. X times 1 is x, so I'm going to subtract. This will be x cubed minus x cubed plus x is a negative x, which is a smaller power than what I have for my denominator right now. So I'm going to leave it there for my remainder. So this is x plus negative x over x squared plus 1 is the same thing as x cubed over 1 plus x squared. Okay, so that means if I want to integrate x cubed over 1 plus x squared, I could integrate x plus negative x over x squared plus 1 instead. The integral of x cubed plus 1 over x squared dx is the same thing as the integral of x plus negative x over x squared plus 1, since these two are the same with long division. Okay. Okay, any questions on what we've done so far? I'm going to zoom out. Okay, so because integration is repeated addition, I can split this integral up into two separate integrals. I'll have one integral for the integral of x and one integral for the integral of negative x over x squared plus 1. For this integral, if I say u is equal to x squared plus 1, then u prime would be equal to 2x dx, which I don't have on top. I've got a negative x dx. So I'm going to break this apart. If I multiply by 2 and divide by 2, that'll give me the 2 that I need for my constant. So this integral will become negative 1 over 2 times 2x dx, which will leave me with a negative 1/2 that I can pull out of this outside this integral. So that gives me the integral of x dx minus 1/2 times the integral of 2x over x squared plus 1 dx, which we can then make our U-substitution for. Okay, so if I integrate this is the integral of x, which is x squared over 2, and then minus 1/2 times the integral of u prime over u. So that's minus 1/2 times the natural log of u plus c. And we can resub in for u. If u is x squared plus 1, and this will be x squared over 2 minus 1/2 of natural log x squared plus 1 plus c for our final answer. Any questions on what we did here? Okay, I'm going to check, make sure nobody's actually talking to me. Nope. Okay. So I think I'll do one more, and then we'll stop there and let you guys try a couple. So let's do the integral of I'll do x to the 4th minus 3 over x plus 3. So I could set this up as x to the 4th minus 3 divided by x plus 3. In order to get an x to the 4th power, I'd have to multiply x plus 3 times x cubed. So that's x to the 4th plus 3x cubed if I multiply by x cubed. I'll subtract that from what we had originally to get negative 3x cubed. Okay, I don't have any x cubed terms here, so I'm just going to leave it like that. In order to get a negative 3x cubed from x plus 3, I would have to multiply x by negative 3x squared. Negative 3x squared times x is negative 3x cubed. Negative 3x squared times 3 is negative 9x squared. And I'll subtract that from what we had originally to get 0 plus 9x squared. Again, don't have any x squared terms here, so in order to get a 9x squared, I would have to multiply x by 9x. So that'll give me 9x times x is 9x squared, and 9x times 3 is 27x squared. So if I subtract that from what I had originally, I'll get a negative 27x. Again, I don't have any x terms here. To get a negative 27x, I'd have to multiply x by a negative 27. That'll give me negative 27x, and then when I multiply negative 27 times 3, I would get negative 81. If I subtract that from what I had originally, that gives me a positive 81, but I do have a negative 3 here. So that's 81 minus 3 is a 78 for my remainder. Plus 78 over x plus 3. Okay, so what that means is this whole integral is equal to this polynomial. good way to add another page. Let's do this. Okay, so we said this integral of x to the fourth minus 3 over x plus 3 is equal to this polynomial. The integral of x cubed minus 3x squared plus 9x minus 27 plus 78 over x plus 3. So if I integrate this right side, all of these terms I could solve through straight integration. This one I would have to do U-Substitution, where u is x plus 3. That means u prime is just dx, or 1. So this would be, for this term only, 78 times the integral of u prime over u. For every other term, I can just integrate normally. Okay, if I integrate x cubed, I'll be left with x to the fourth over 4. If I integrate 3x squared, I'll be left with 3x cubed over 3. If I integrate 9x, I'll have 9x squared over 2. If I integrate 27, I'll have 27x over 1. If I integrate u prime over u, I'll end up with a natural log of u plus c. Okay, we said u is x plus 3, so I can resub to get x to the fourth over 4 plus x cubed plus 9x squared over 2 minus 27x plus 78 times the natural log of x plus 3 plus c, if I want to simplify. All right, so that's polynomial division. Anytime you've got an improper fractions, that means your power is larger on top than it is on bottom. We can divide those polynomials out to get something that we can integrate. Any questions on anything we've done? All right, you guys are super quiet. So I've got this file that I've sent through WeChat, and I'll send through Skype in a second. This is integration with improper fractions, with a handful of problems to complete. Right now we've got the homework from, that would have been Tuesday from this class was due this morning. The homework from Thursday from this class is due, I believe we said Wednesday. I'm going to ask for today's homework on Friday then. We'll see if we can catch up for Wednesday. Okay, so thank you very much for coming. If you guys have questions, let me know. Otherwise, I will see you guys on Wednesday.